Yeah, only 1 minute late. This is Code Jam round 2. Top 1000 or so, maybe 200 people advance to the next round. Still, I will try to win. First is an interactive problem. I think instead of sorting, I will first arrange them in some different order. If I know where the minimum is, let's say it's here, I can put it at the beginning and be left with the remaining n-1 elements. That's bad. I can go recursively to both halves, but once I get to very small ranges, it will be bad again. How can I distinguish between two greatest elements? Oh, maybe 6 is logarithm of n. So log of n is fine. It's around that. So is it just this? I need a program to check that. Yep, it is good enough. Very strange problem. I guess I can as well just do it here. Single test case. What are we doing here? Minimum query. Swap. You're done. Positions are 1 through n. Yes, I think they are. From I to the end, flash, read the answer, and swap. Print D and flash. And I guess we need a judge. Or can I run tests? I guess not so easily. Where am I? Didn't I? Okay, it's here. This is interactive runner. And I will need testing too. What do you want? I smaller than J, I guess that's wrong. To 1. I is greater than X? Oh, there is a response. Was it too slow? T goes first, then N. Doesn't print anything else. Oh, only here we check. No big tests. Oh, that's the only test. So I guess that's it. Ten minutes after the beginning of the contest, first problem done. Okay, I thought that just only 2 people solved it. Matryoshka. Cool. First done. Second. Every next polygon needs to have a number of vertices being divisible by the previous one, I think. The last value is at least 3. We want to say that 33 is 3 plus 6 plus 24, where every next number is a multiple of the previous one. I want to maximize the number of numbers. Well, everything is divisible by 3, so I can check divisors. And then this is possibly 3 times 11. And then I need to represent 11 as 1 plus stuff. So I subtract 1, and 10 needs to be represented as just, I wonder about the maximum answer for 10. And that's it. I don't know if this will be fast enough for all possible n's, but I guess it won't take a lot of time to try this. Matrigons. Oh, I didn't copy my templates. Let's be careful here. Hash this number in test case. This will be good. I think so. Right, we iterate over possible divisors of size at least 3. I don't know if I should do memoization. Oh yes, obviously I should. But then it's will I touch only divisors? Should I compute answers for all n's? Yeah, I will do that. Just because I'm not sure about the speed. We iterate here over what, multiples? I guess I need to store the divisors, but that's fine. We consider writing, for example, 33 as 3 times 1 plus stuff. Right, so answer of n should be maximized with 1. This is already the first value, and the remaining is answer of n divided by x minus 1. This will possibly be 0, but that's fine, this value is 0. That's slow. Worked here. Three and then 6, I guess. Wait, why this? I maximize, but I start by just saying I'm taking one element. This should say 2. I see. In terms of this, we are allowed to go with double. Wait, what? Okay. There is fake answer and real answer. And fake will allow anything including 3. Okay, worked here. 9. I don't know, let's submit. I'm looking at 40th place right now. This is good enough in terms of getting to the next round. Do we want a quick look at the rules? 1,000 people will advance. Passed. Okay, I'm top 50, 36. Yeah, okay, hidden pancakes should be easier. By the way, we are 20 minutes in, 2 hours left. Were there some hidden tests in the previous problem? No. Okay. Let's analyze what happens when first there must be 1 given, then the second one is 1 or 2, so it can be covered or not. Maybe drawings will come handy. That. Let's say there is 3, then 2, or maybe 1, then those should be values actually. 7, 4, and then let's say there is 5. We went with order 1, 2, 2. We always know when in this prefix, if we know which pancakes are active, let's say this one, and this one, and now we're given some value here, because we knew value there, the difference between them will tell us how many pancakes we covered. So now we add this one, and if it covered 2 previous pancakes, then we know we should take from the stack this and that. So kind of this dependency. This pancake was apparently bigger than those 2. And then there's something here. Of course, it's also bigger than everything here, everything there. If there's some more stuff, those are bigger for sure. For this, the last visible is always there, just before this guy. Basically, we're saying that this one is here greater than everything here. Here is the first greater. Maybe this is enough of an information. For every new value, we know where was the previous bigger value. If I mark this in green, and for this one, it's here. Previous bigger. For the new guy here, maybe this is previous bigger. For the new one here, maybe this is bigger. Is this enough? And maybe then we should go from right to left. I like this new green interpretation. Can this be true? This was smaller, so it's like 5, 7, and I'm pointing to 5. That's impossible. This is, I guess, possible. Maybe this is possible as well. And that. If that's the case, then whenever we see this line, big line, maybe we should count how many ways there are to reorder those, how many to reorder the outside world, and we will combine that. Look at the first element. There are some arrows pointing towards it. Among all the elements. If we look just at this, the leftmost must be greatest, rightmost must be smallest, and then there is stuff here. And we assume that just on the left we have infinity. Then what? We destroyed this. Maybe I should look at the biggest line, like this one. Apply this logic here. And then also count stuff there. Okay, I like this idea. There can be many green lines pointing here, but I choose the biggest one and I look at those two intervals. This one and this one. I will in both count number of ways to put elements there, and with some kind of binomial coefficient I'll combine all of it. Then this is the biggest element here, this is second biggest in the whole sequence. What if this is not the biggest? Okay, so for some values, we assume first that at the beginning there is infinity. There will be some arrows pointing towards infinity. Right, maybe here, like that. And for now it's enough. Then I go here. This is the biggest element, and here we have something smaller and something smaller, so we are cool. If there are no arrows pointing here, but there is at least this one, and then this means it's the biggest guy, so still it works. Okay, yeah, we need to do this. First add a fake infinity. Also, when we enter some part, just to the left of it we imagine infinity. Then what happens if it's like this? There's infinity here, the only green arrow is that. Then the two yellow areas are empty, one here, this one of size n-1, so we're good. And this is the biggest element. In blue will be the biggest. This is biggest. Green arrows refer to, they denote previous greater element. Okay. What do we have? Pancakes. Can I go from 0? This says how many are visible. I need those arrows. Also, when I recursively go here, what do I need is inside some interval was the rightmost guy pointing here. Then for every position, including this -1, then it will be better to do this in order to have a fake 0 position. For this guy, I will know what arrows enter it, and then when I go recursively to this yellow interval, in this guy, I will know the green arrows coming in. I will binary search there to see what's the rightmost one among those starting in the yellow area. This is impossible, everything else is possible. I need to compare this. Let's see. If a moment ago there was 5 and now 6, then nothing happened. Like that. Let's say this was 8. Then I think I skipped 3. Yeah. Skipped 3. There is a stack. I will call it, well, stack. If this was 0, then 0 plus 1 minus 1 is nothing, so nothing is skipped yet. And we can start from I being 1. What are skipped values? Oh, I should just that many times pop back. I could also resize. Let's do a resize. The element 0 should still be there. And then we add new element, and just before that we know what's the previous bigger. Previous bigger of I is stack back, and in coming in for this guy are I. For every position I want to know what green arrows come here. Then I need a recursive solution. And I will need binomial coefficients, I think. Now we are able to inverse modulo mod. We can, I guess, precompute factorials and their inverses. Inverse factorials, and then binomial coefficient function. Like that. From 1 to n. I need to look at green coming to n minus 1, upper bound it, to find the first one after r, and then we will do minus minus. We need in and all that stuff. This will be int. Now this is position of the biggest. I need to solve left part and right part. And I need to do the two sizes. X minus L, okay, R minus X, yep, and this will be among the two, choose elements that will go to the left side. $76. It seems I don't print the answer. It's not very smart. 0. In first sample, this is the proper order, and let's see, previous bigger. For first one it doesn't exist, and then position 1 doesn't exist. Yes, this is good. How do we get here 0? Maybe factorials are wrong? Maybe I have factorial with 0 elements? Something is definitely wrong with factorials. Factorial of 0 is 0. That's not good. Not my proudest moment, but we got it to work here, and I don't want the debugs. Say I will comment them out. I guess I want to submit. I don't have a good time. If I want to be in the top, then I need to make risks. I guess I should just run it for some n bigger than 13 to see the running time, I guess. And overflows. I passed the small test. Let's see. Let's say that vi is vi minus 1 plus 1. First that. Then to fifth. Right, but then okay, looks good. Maybe should have checked that before running stuff. Oh, Rodeusz won. Maybe, depending on whether this is correct. 36 minutes, and I'm at what? 44, and one problem left. Okay, new goal, top 100. Swap two adjacent tiles or flip state of something. Grid is very small, so it can be flow. With swaps, I kind of make one cell travel to some new place. If there is a big grid, let's say we just type A everywhere, and there is a single B, and I need to, from this, get something like that. Then whether I should do it by twice flipping or by swapping multiple times, it depends on the ratio. If I swap something, it just means I don't want to flip. There can be a big grid with multiple very separate one from each other spots where we need to move B by like 5 units, here by 7 units. So the ratio will be very important, ratio between F and S. Maybe it's some kind of matching or Hungarian algorithm, which is basically a flow. For every B in the initial grid, I have some cost of making it go to a new cell in the final grid. If I'm only allowed swaps and the number of Bs is proper, then the problem is exactly to find cheapest matching, max matching with smallest cost. But we can also flip. So should we say that, okay, then for every position of B in the first grid, with one position of B, to position of B in the second grid, there is a cost of path by using swaps multiple times. Also, from some fake vertex to this one, there's a cost of single flip. Cost of single flip. From a lot of, there will be a lot of fake vertices, and between them, or like there will be one but with big capacity. And this. I think we need this network, and we're looking for max flow min cost. right? Those moves are independent. And I just want all the Bs to be in proper places, and they shouldn't be if they are in a wrong place. They can be it can be resolved either by flips or by path of swaps. Yeah, looks fine. Then I need to find the code for my code for flows. Where is it? I'm on my second monitor. I'm going through the files. Come on, where is it? I mean cost max flow. Found it. Now copying this. I guess I need to provide the source. I'm not sure. Old Warsaw University. First document. And this is namespace. There is init. Oh, I need the defines like for. Why do I use such a strange max flow? I'm just recompiling, checking the error at the bottom, and then adding the proper define. Alright, then there's add edge and init. And this is not a struct, but is it enough to do this? I don't think so. Oh, so bad. No clear in queue. Right, then there's my solution. What's infinity? 1,000,000,005 should be enough. Rows and columns. This is one grid, and then there are the two costs. Height, width, flip cost, and swap cost. What do I need? Min cost, max flow, inside min cost. What is M? Hopefully that's a good start. I need to of course create n, but here the logic from there. For every cell in the grid, for every cell in the second grid, we do something. Oh, I need to know. I think I will have a function that will just read the grid and give me positions of values of one type. Read M, let's say, or type G. Found everything of type G. And now, what now? Now we follow this. There's a cost of swapping. Bad naming. Oh, let's add that first. Still bad naming. That's the distance, and we need to add edge. From the hashed ID of this cell. To this one. I guess then cost and capacity, right? Yeah, capacity 1, cost I need a fake vertex. Like this, then I need hash. This will give me ID from 0 to h times w minus 1. Okay, like that. We add an edge, this kind of edge. Right, and comes some extra edges. From start to every A, capacity 1 cost 0. Something very similar here, but to the end. From this guy to the end, size 1 and this, and 2 extra edges between fake stuff. We have from those to fake 1, then I need from fake 1 to the end. Done. Three and 4 I got wrong values. Again, very wrong. Let's consider not doing any swaps or not doing any flips, because then it's easier to say what should be the answer. Swapping the path. This is flip of type 1 and this is flip of type 2. With just flipping I got the same stuff. Let's see. One flip, second, third, fourth, and fifth. I see 5. Oh, I should do this only if there isn't such a cell in the other guy. If what find, then I need to flip. Not B. It's called second. No, not this. Four. But it should be 5, right? Maybe I added some wrong edges. Oh, I know what can help. Should I really add this edge in the other direction? I guess I should. There are 5 edges with cost 1. Max flow is just for Y. Should I do something with for actually all the cells? If something is in proper position, we will never touch it. And why bother doing this? I'm not good at flows, by the way. If you didn't realize that yet. If this is present, that's a little bit better. Less chaotic. Still, we only allow flipping. If I flip, shouldn't this edge go to the end? Why fake 1? How is this a flip? This is a flip. Because it has a cost of F. This just says that from 0 there is an edge to this guy, and from this one we either should use a flip or something else. Should I just say that we go to n? Yes, I think that's what I should do. Now that's worse. Because this is obviously 0. Answer is still 4 instead of 5. Why is there an edge from 0 to 17? Yeah, that's plus. No, maybe now it works. No, it doesn't. So I hope that from here to there is something of length 1. Okay. 14. Does 14 exist otherwise? Yes, it does here. Actually, I want to focus on the first test. 14 doesn't exist in this test. And what I should do is swap those, swap this, and then one flip. Hence the cost of 3. This will have index 1, this index 2, this index 1 plus 8, that's 9. So from 2 to 9. Yes, there is this thing. So we will follow this, 2 to 9. And then 9 to the exit. There are no other edges going out of 9, so I don't see what else we can do here. Maybe I provided wrong data. Capacity 1. Cost of distance. Come on. I hope I'm still good to advance. Right? Yeah, okay. This is still, assuming some people didn't solve full versions of problems, I'm top 100. I'm even without solving this 173rd. So I could give up now, but I want the full score. I guess I can draw it. What if I didn't allow to flip? And then 2. That's right. And as an extra, I only here allowed to get from 0 to the cell in B, and from cell in A to directly to N, both with capacity 1 and cost F. I'm going to draw the graph. Everything has capacity 1? Yes. The cost here is 0. I think every vertex should be doubled, so I would allow only one unit to pass through. But let's make sure about that. 0, 11 is cost 1, 11, 17. No, every vertex is limited. Do I really want max flow? I think I don't. But instead of max flow, I should just say that I should pass through every vertex 2, 9, 4, 11, 8. Not necessarily do a max flow. Because of max flow, I try to do this, this, that, and this. Maybe I should ignore the fact that I can fix 9 and 11. I should do something only with 2, 4, and 8. And in some way reward for going through 9 and 11. Maybe those costs should be negative, I'm not sure if that's allowed. Okay, I will destroy those edges. I will not even use them. But if I don't go through 9, then I know I would need to use that. So here I can put cost -1, and here I can put cost -1 if negative is allowed. With cost of 1. So I don't know what the pair stands for. I should add something back later. It is this plus B size, I think. The number of vertices like 9 and 11. Three and 4. Not good. No, this is not cost of, it's not that I save that much, I save this much. Because otherwise I need to flip. $3,003, nope. Cost I think can be negative because there were some edges with negative cost. I can as well increase the cost of using those. I think it should be equivalent. this stays at 0, but if I use some of those, that's going to n. I have an extra cost of f, because of it means one of yellow edges will need to be used. I'm flipped and it triggers the flip of one more guy here, and there's then some difference, right? The difference between sizes. This is not easy to test. Free. This is if what flipping is cheap. That's right. I guess let's submit this and hope for the best. I should and I will do a few more tests. It will be judged only on test set 1, where flip and swap are equally expensive. So maybe I'm doing something very, very stupid, and somewhere I need f instead of 1. But this cost is dist times s, that's fine. So do I ever put cost of 1? No, I don't think so. Can this be very slow? It can. Oh. 100 cells times 100, no, that's not wrong, but that's fine. But CRR, it's bad that I left it. It will take time. 100 square per test case. And I think that CRR always flashes the output, so it's much slower than just cout. How is Poland doing? I'm not very fast today. An hour and 30 minutes. Still pending judgment. Oh, in my defense, I'm tired today. Oh, I said I should do more tests, and even though I'm really not motivated, I need to do that. Time limit exceeded. Is it because of CRRs? Or is it because of flow on 100 vertices and 100 square edges? I can check with random tests. Swapping should be a bit cheaper, right? So usually. Right, like this. Was that an infinite loop? I think I'm reading wrong, right? Oh, twice. The grid should be printed twice. Is something wrong with clearing? Do I run init? I don't. I do not. I don't want to see the debug stuff in the output. Now it should be faster. No, removed it from Wrong line. And I only see swapping now. Oh, it's just 10 by 10. What do I do? A good lesson might be that if something is being judged for so long, and I waited multiple minutes for the verdict, I should already assume that it's time limit exceeded. I will do that next time. I will just think, okay, time limit exceeded, let's check the max test, because it is being judged so long. I passed the first test, and I never use 1 as the cost, I only use F and S, so I think we're good. Let's just check the order. FS. FS, yep. $256. That's a nice round number. But with wrong items, actually only 1, so still for the next 4 minutes somebody can overtake me, and maybe I will be 257 for already 3 more minutes. If somebody gets all problems accepted and they don't have this plus 4 minutes penalty for a wrong submission, they will beat me. And of course a lot of people will fail a problem or two. Well, only the last 2 problems can be failed, but still, there will be some. Hopefully not me. Yeah, let's see how safe I am. 100 people per page. And what is now happening around place 1000? Is this problem easy compared to matrigals? Hopefully people who solved hidden pancakes and only got here small subtask, they don't have here big subtask. If that's the case, then right now I would even say that with just all the visible points, I will be high enough. I will be in top 1000. Yeah, but if I don't get just one big problem, then I mainly lose. Well, the worst thing is if I don't get this one. Of course, optimally, what I should do now and until the end is I should just test my solutions. I should write a brute force and see, of course, this brute force here, it would check all the possibilities of what to flip, what to swap, just exponential, and for various small tests I would check if my solution works. Well, in hidden pancakes, yeah, the brute force is just to iterate over stuff, but I know that for small tests here I'm good, so only overflows are dangerous, and because of that, now that I'm saying that, let's check if I have some overflows. Multiplication is good. Here, multiply this modulo mod times modulo mod, casted to long, good. This is not huge, it isn't. Okay. Multiplication, I don't see any possible overflows. Then I'm happy about my result. And I know I should test this, but still, 10 more people got higher than me. I predict from this a place like top 100, I hope, maybe 150. We'll see in 45 minutes. And also just after this video, I'm going live on Twitch, and the video is also available on YouTube. So in the description, check out the link to that analysis of solutions live. Thank you for watching. Bye.